సో క్లాస్ జరుగుతుంది. ఎవరికైనా డౌట్స్ ఉంటే దయచేసి డౌట్స్ అడగండి. సో మీరు డౌట్స్ అడగకుండా ఉంటే మరి ఇక మీరు క్లాస్ వింటున్నారా లేదా అనే డౌట్ తోటి మేము ఉన్నాం. ఓకే, సో
Very good morning, students. So in this video we are going to discuss the last class continuation, that is the buffer solutions. Buffer solutions. So what are buffer solutions? What will be the purpose of this buffer solutions? So generally these buffer solutions are used in research programs and also used in various chemical industries for manufacturing chemicals, and also it is used in softening of hard water or hardness of water. How to calculate the hardness of water? So by hardness of water experiments, this also buffer solutions are used. So before we going to discuss that one, first, what are buffer solutions? The solutions which maintain a constant pH. The solutions which maintain constant pH. Constant pH on addition of strong acid or strong base or by dilution. The solutions which maintain constant pH on addition of strong acid or strong base or by dilution. So such type of solutions are called as what now? Buffer solutions. Buffer solutions generally resist the change in pH of the solution by adding little bit of acid or little bit of base or by adding water. The solutions which maintain constant pH on addition of strong acid or strong base or by dilution. So such type of solutions are what now? Buffer solutions. Why these solutions maintain the constant pH? Because buffers possess a reserve acidity as well as reserve basicity. That's why buffer solutions maintains the constant pH on addition of acid or on addition of base or by diluting with water. The solutions possessing what na? Reserve acidity character as well as the reserve basicity character. So these are the solutions are called as what na? Buffer solutions. This is a very, very important point because they possess what na? Reserve acidity as well as reserve basicity character. So this reserve acidity will nullify the reserve acidity. Reserve acidity will nullify the effect of added base, and reserve basicity of the buffer will nullify means no effect. Reserve basicity will nullify the effect of added acid. So this is the added acid, this is the added base. This reserve acidity will nullify the effect of added base. This reserve basicity will nullify the effect of added acid. That's why buffers generally maintains the pH of the solution. buffer solutions maintains the constant pH on adding acid or base or water, because they possess a reserve acidity as well as reserve basicity. Reserve acidity will nullify the effect of added base. Reserve basicity will nullify the effect of added acid. So this is the major important character of the buffer solution. After this, we are going to discuss about the types of buffer solutions. Types of buffer solutions. So what are the buffer solutions? There are various types of buffer solutions. Number one is acid buffers. Acid buffers is the one of the important type of buffer solutions. So what are acid buffers? So in this, the first type it is type 1 buffers. Type 1 acid buffers are, so mixture of weak acids and its salts of salt of strong base. So what are the mixture of weak acid and its salt of strong base is what? For example, acetic acid is the weak acid and its conjugate is the CH3COO minus. CH3COO minus and Na. This is the weak acid and it is the salt of strong base. This is the weak acid and it is a strong base salt. Strong base salt, this one. Salt of strong base. Acting as what na acid buffer. Mixture of weak acid and its salt of strong base. Example, weak acid is the CH3COOH and salt of its strong base is the CH3COO Na. Suppose HCOOH, this is the again weak acid, it is an organic acid, it is weak acid compared to gentle acids like HCl, H2SO4, etc. SCOH is the weak acid and its salt is what na HCOONA. So it is also a combination of weak acid and its salt of strong base. Therefore, it is also an example of what na acid buffer type 1. And the third example for the acid buffers, suppose you take HCOOH, again HCOOH plus this is the HCOONA. Suppose you take the calcium formate HCOO taken twice. It is also, this is the weak acid and it is the salt of strong base. HCOO minus is the strong base. Their salt is the calcium formate. So weak acid and its salt of strong base also acting as a buffer. And the fourth type it is, suppose you take the H2CO3, this is the carbonic acid, it is also weak acid and its salt means NaHCO3. So NaHCO3 is also a salt of strong base. And the fifth type it is, suppose you take the H3PO4, H3PO4, H3PO3, you take H3PO3, this is the, what now this one, phosphorus acid and Na2HPO3. So it is the salt of strong base. It is also acting as a, and the next it is H3BO3, boric acid. This is the boric acid and Na2B4O7 10H2O, this is the borax. So Na2B4O7 10H2O, this is a borax. So mixture of boric acid and borax, they will acting as a acid buffers. And the seventh it is, suppose SCN is a weak acid and NaCN is a salt of its strong acid, salt of its strong base. Strong base salt is the NaCN HCN is a weak acid. So combination of this HCN and NaCl is also acting as a, and next it is suppose you take the HCN, NaCN, H2S, NaHS, H2S and NaHS. So this also acting as a acid buffer. So acid buffers are what now? Mixture of weak acids and its salts of strong base. CH3COOH is a weak acid and CH3COONA is a strong base. So these are acting as what now? Acid buffers. And the next it is type 2 of acid buffer solutions. Type 2. So what are the type 2 acid buffers? Acid buffers type 2. For example, you take the CH3COOH. This is a weak acid. Now we are adding what now? Strong base. So here this is the NaOH is a strong base. By adding these two, will acting as a acid buffer solution in the mixture. So how this CH3COOH NaOH combination will acting as a buffer? So when we are adding NaOH to acetic acid, you will getting what now? CH3COONA. CH3COONA plus water. CH3COONA plus water. So now, in order to acting as a base, in order to acting as a acidic buffer, you must take this is in excess. This is in excess and this is in limiting. You must take this is in limiting and this is in excess, then it will be acting as a acidic buffer. For example, this is you take 5 moles and it is you take 2 moles. So now it is in limiting, this is in excess. This is an excess reagent, this is a limiting reagent. This is we are taking in excess amounts, this is in we are taking in limiting limiting amounts. Suppose if you take this as 5 moles, this as 2 moles. So now combining these two, you will getting what now? CH3COONA plus water. So this is the limiting. This will decide in the formation of CH3COONA. So initially it is 0. Here also initially it is 0. At initially there will be no formation of CH3COONA and water in the reaction mixture. Therefore, these two are 0 zeros. So after the reaction, this 2 moles of NaOH will decide in the CH3COONA formation. Therefore, you will getting this 2 moles. So after completion of the reaction, CH3COONA is 2 moles and it is also 2 moles. And now this total 2 moles will consumed into this products. Therefore, after the completion of the reaction, this NaOH will be 0. But this is 5 minus 2, it is equal to 3 moles at the time of completion of the reaction. Completion of the reaction, this is 3 moles, this is 0 moles. Now this total NaOH consumed into this CH3COONA water with the reaction of this acetic acid. Therefore, here 0 moles of NaOH in the reaction mixture, but we have only this CH3COOH, this CH3COOH in the reaction mixture and this CH3COONA and along with water now. So this will acting as what now? This is the acidic buffer. This is what now? This is the acidic buffer. So what kind of buffer now this is? This is the acidic buffer. So acidic buffer is a mixture of what now? Weak acid and its what now? This is CH3COONA is a salt of strong base. Salt of strong base. So mixture of this weak acid and its salt of strong base is acting as what now? Acidic buffer. So therefore, this is the indirect method for the formation of buffer solutions, but the direct method is by combining acetic acid and CH3COONA, you will getting the direct buffer. But here we are adding what now? Acetic acid to strong base NaOH. You will getting what now? These two, CH3COONA plus water. But this must be taken in excess and this must be taken in limiting. This is in excess, this is in limiting. This is 5 mole, this is 2 moles. If you take this is 10 mole, this is 5 moles. So in that way only you will getting what na acid buffer solutions. So this is a type 2 type of buffer solutions. And one more example in this, suppose you take the HCN plus barium hydroxide. So HCN plus barium hydroxide, you will getting what na barium cyanide plus water. So 2 moles water and this is the 2 moles now. So this is the weak acid or not? This is the weak acid. And this is the strong base. So this is weak acid, this is the strong base. Now you will getting what now? BaCN2. So combination of HCN and BaCN2 is acting as a acidic buffer. But here we are adding what now? HCN2 barium hydroxide, giving what now? Barium cyanide plus 2 moles water. So initially, suppose you take this is the 10 moles. This is the 10 moles and this is the 4 moles. So you must take what now? This one is in excess. This is the excess reagent. This is excess reagent. This is excess reagent. This is a limiting reagent. This limiting reagent will decides the product formation in the reaction. Therefore, barium hydroxide is how many moles now in this case? 1 mole. Therefore, barium cyanide also you will getting what now? Initially it is 0, it is 0. But it is how much moles now? This is 4 moles. Therefore, for 1 mole you will getting the 1 mole of barium cyanide. For 4 moles you will getting what now? 4 moles of the barium cyanide. This is the 4 moles. Now for 1 mole it is 2 moles. Therefore, you will getting what now? This is 1 mole. This is 2 moles. For 1 mole of barium hydroxide you will getting what now? 2 moles of water. For 4 moles of barium hydroxide you will getting how many moles now? 4 to the 8 moles. Therefore, this is the 8 moles of water. So for 1 mole you will getting 1 mole of barium cyanide. For 4 moles you will getting what now? 4 moles. For 4 moles 4 moles. For 1 mole of barium cyanide. For 4 moles of barium hydroxide, how much now? After completion of the reaction, 4 moles of barium hydroxide forming how many moles of barium cyanide? 4 moles of the barium cyanide, because for 1 mole you will getting 1 mole. For 4 moles you will getting the 4 moles. For 1 mole barium hydroxide you will getting the 2 moles. For 4 moles you will getting what now? 8 moles of water now. Now, after completion of the reaction, this 4 moles totally consumed. Therefore, after completion, barium hydroxide should be what now? 0. For 2 moles, you will getting the 1 mole of barium cyanide. For 10 moles, for 2 moles HCN, you will getting 1 mole. For 4 moles, it will be what now? 8 moles. Therefore, initially it is 10 moles and this will be 8. Therefore, totally how many moles of HCN left in the reaction mixture? 2 moles of the HCN left in the reaction mixture. Therefore, this is 0, this is 4 moles. Therefore, this totally, this HCN with this totally it is acting as what now? One acidic buffer. 2 moles HCl gives 1 mole barium cyanide. So this is 2 moles, this is the 4 moles. By combining these two in the reaction mixture, what are the left? Barium hydroxide is 0, water is 0. Water initially 0 and after it is 8 moles. But there is a negligible change by adding water to the buffer solution. Therefore, if water is present, no change in the pH will also there now. Therefore, 2 moles of HCN and 1 mole of barium cyanide, or HCN and barium cyanide combination is acting as what now? That is the acidic buffer. So therefore, this is a acidic buffer. This is the acidic buffer. This is what now? Acidic buffer. So this is the type 2 buffers, acid buffers. So by directly adding say CH3COOH, CH3COOH, Na, you will getting the acidic buffer. By directly adding HCN to barium cyanide also you will getting the acidic buffer. But here we are adding what now? Strong base to acetic acid. By adding strong base to acetic acid, you will getting CSCONA along with water. But after the completion of the reaction, this whole mixture, because this NaOH is 0, here in this reaction mixture, NaOH is 0 after completion of the reaction. If water is present, there will be no effect in the change in pH. There is a negligible change in pH by adding water. Therefore, no effect on water, no effect. If water is present in the reaction mixture, there will be no change in the pH. Therefore, if water is water, leave it. Only this CSCOH and the CSCONA will acting as what na? This is the acidic buffer. So here SCN and this barium cyanide will acting as what na? Acidic buffer. So this is the type 2 type of acid buffers. So after this, we are going to discuss the next. It is the basic buffers. Second, it is basic buffers. So what are the basic buffers? So what are basic buffers? So buffers, this is the second type of buffers now. So mixture of weak bases and its salts of strong acids. Mixture of weak bases and its salts of strong acids. So this is the type 1. Type 1. So mixture of weak base and its salt of strong acid. For example, ammonium hydroxide is a weak base. Ammonium hydroxide is a weak base. And salt means NH4Cl. This is the strong acid salt of strong acid. Ammonium hydroxide plus ammonium chloride. And second, it is the glycine plus glycine hydrochloride. Glycine hydrochloride also acting as a buffer, basic buffer solution. And this is the ammonium hydroxide plus ammonium bromide. Ammonium hydroxide plus ammonium sulfate. Ammonium sulfate. Ammonium hydroxide plus ammonium nitrate. So all these will acting as what na? Buffer solutions. What kind of buffer solutions na? These are the basic buffer solutions. So ammonium hydroxide, ammonium chloride. Ammonium hydroxide is a weak base. Glycine is also a weak base. This one also weak base. This one also weak base. This one also weak base. So ammonium chloride is the salt of ammonium hydroxide is a weak base. Weak base conjugate is the NH4 plus. So this is weak base. Therefore NH4 plus is a strong base, strong acid. So strong acid salt is the NH4Cl. So glycine is the weak base and glycine hydrochloride is the strong acids. Ammonium hydroxide is a weak base. Ammonium bromide is the salt of strong acid. NH4 plus is the strong acid. NH4OH is the weak base. So therefore these will acting as what now? Basic buffers. These will acting as what now? Basic buffers. And next type 2. So what are the type 2? These are the direct buffers. By adding two, one is weak base and its salt of strong acid, you will getting the buffer. So in the previous one, what na? So CH3COOH. Suppose you take the ammonium hydroxide to strong acid H2SO4 or HCl. So ammonium hydroxide and HCl. So by adding HCl to this ammonium hydroxide, you will getting what na? Ammonium chloride. Ammonium chloride plus water. So ammonium chloride plus water na. So this must be taken excess. This must be taken excess and this must be taken excess and this must be taken in limiting in small amounts. Suppose if you take this is 5 moles of ammonium hydroxide and 2 moles of HCl. Initially you take 2 moles of HCl and 5 moles of ammonium hydroxide. So initially there is no formation of ammonium chloride and water, therefore they are 0 and 0. After completion of the reaction, This is the limiting reagent, this is the excess reagent. So limiting reagent generally decides the formation of product. Therefore, this totally it will consumed in the reaction. Therefore, you will getting the 2 moles of ammonium chloride and 2 moles of water. 2 moles of water. And then this will be 2 minus 2 means what now? The leftover amount is the 2 minus 2, it is equal to 0. And the leftover amount of ammonium hydroxide, from this ammonium hydroxide, only 2 moles of ammonium hydroxide will react with the HCl. From this ammonium hydroxide, only out of 5 moles, only 2 moles of ammonium hydroxide will react with HCl, because limiting reagent will finalize the product formation. Therefore, 5 minus 2, it is equal to 3 moles. 3 moles of the ammonium hydroxide is present in the reaction mixture after the formation of the ammonium chloride and water, or after the completion of the reaction. Therefore, this ammonium hydroxide, this is 0 in the reaction mixture. HCl is 0 in the reaction mixture. Initially it is 2 moles. After the completion of the reaction, it will be 0. Therefore, there is no HCl in the reaction mixture. Now this totally it is acting as what now? One basic buffer. So ammonium hydroxide and ammonium chloride. This is the ammonium hydroxide, ammonium chloride combination. So this will acting as what now? This is the basic buffer. This will acting was, this is the basic buffer solution. This is the basic buffer solution. So this is the second type of buffer solutions, or what now? These are basic buffers. Now the third, it is the simple salts and its acidic salts. Acidic salts will also acting as a buffer. Will acting as a buffer. For example, simple salt means Na2CO3. Sodium carbonate is a simple salt. Na2CO3 is a simple salt. And its acidic salt means NaHCO3 is an acidic salt. So their combination is acting as what now? One buffer. This is the simple salt and its acidic salt. For example, Na3PO4, sodium phosphate plus Na2H PO4. So this will also acting as a simple salts and its acidic salt solutions. They will also acting as a buffer solution. And the next it is one more type, that is the mixture of weak acid and weak base. Weak acid and weak base. For example, you take the CH3COO NH4. CH3COO NH4. CH3COO NH4. So in this we have what now? Off part is the weak acid conjugate. Off part is the weak base conjugate. So this will be forming by CH3COOH plus NH4OH. So by adding these two, you will getting this kind of salt. This salt is acting as what now? This is the mixture of weak acid and weak base salt. CH3COO NH4 is a salt of CH3COH and ammonium hydroxide. So this mixture of weak acid and weak base also acting as a buffer solution. And one more, that is the HCOO NH4. So this HCOO NH4 is a mixture of weak acid and weak base salt. So this is forming by HCOOH, formic acid plus ammonium hydroxide. So this also acting as what now? This is also a type of buffer solution. So there are various types of buffer solutions. First it is the acidic buffer solutions. In acidic buffer solutions, we will getting what now? By adding directly the CH3COH to CH3COONA, or by adding with the CH3COH to NaOH also, you will getting the buffer solution, that is the acidic buffer solution, that is by indirect. But here we have what now? This is the second type of buffer solutions. In this, the first type it is what now? Mixture of weak base and its salt of strong acid. So this is the weak base and this is the salt of its strong acid. This is the weak base and it is the salt of its strong acid. This is the NH4OH, the weak acid. This is the salt of its strong base, strong acid. This is the weak base. It is the salt of its strong acid. Therefore, all these are working as what now? Buffer solutions. And the second type it is the indirect method. This is the indirect method by forming a buffer solutions. Suppose you take this is what now? This is the weak base, but here we are adding what now? Strong acid. But here we have what now? What is the combination between them now? Ammonium hydroxide, ammonium chloride. This is the strong acid, this is the weak base. But here we are what now? This is weak base, it is the strong acid. So in the indirect method, if you want to prepare the buffer solution, you must place this is in excess and this will be in limiting. So this excess means if it is more than this one, this will be acting as a excess. It is less than this one, this will be acting as a limiting reagent. So limiting reagent will decide in the product formation. So this is the 5 moles, this is 2 moles. After initially this is 0, this is 0. After formation of the product, ammonium chloride and water, this HCl will decide the formation of ammonium chloride. This is for 1 mole of HCl, you will getting the 1 mole of ammonium chloride. For 2 moles, it will be 2 moles. For 1 mole HCl, you will getting 1 mole water. Therefore, for 2 moles, it will be 2 moles of water in the reaction mixture. But here, from ammonium hydroxide also only 2 moles will react with HCl to form this NH4Cl and water. Therefore, the leftover amount it is 3 moles. Therefore, this NH4OH is present in the reaction mixture, but HCl is not in the reaction mixture because already it is totally 2 moles consumed into this NH4Cl and water. Therefore, it will be 0 in the reaction mixture. If water is present, that will negligible effect on the addition of water to the buffer solution. Therefore, if water, that will be negligible effect on the pH of the buffer solution. Therefore, you leave it that one. So this NH4OH and this NH4Cl combination is acting as what now? Again, basic buffer. So this is the type 2 type of buffer solutions. This is the simple salts and it acidic salts. Simple salt is Na2CO3 is a simple salt, and its acidic salt means presence of H plus. This will be acting as a acidic. So this is also again one more, and this is a mixture of weak acid and weak base combination will also acting as a buffer solutions. So in addition to this, we have so many types of buffer solutions. So before we go into that one, first how these buffers will resist the pH constant. So that means action of acidic buffers. For example, take one acidic buffer, that is the CH3COOH plus CH3COONA. This is the weak acid and its salt of strong base. This is the weak acid and it is the salt of strong base. So now, actually this is the weak acid acting as a weak electrolyte. This is a strong acid acting as a strong electrolyte. Therefore, in the reaction mixture, CH3COOH remains in unionized form because it is a weak electrolyte. But CH3COONA being a strong electrolyte, completely ionized, because strong electrolytes generally undergo complete ionization, whereas a weak electrolyte undergo partial ionization. Therefore, composition of the acidic buffer will be CH3COOH, this is in ionized form, whereas CH3COO-NA is in completely ionized form. Therefore, this will be like this only now. So CH3COOH is in unionized, whereas CH3COO-NA is in ionized, completely ionized. So here, suppose if little HCl, if little amount of strong acid that is HCl or H plus is added to acidic buffer, what will happen? That added H plus, that added strong acid, that is H plus converts the CH3COO minus of acidic buffer into weak acid. For example, CH3COO minus plus, this is the strong acid, this is the added strong acid, this is added strong acid, this is the, this is what now, this is the strong base, this is the strong base of the salt of strong base, this is added strong acid. This added strong acid converts the strong base into weak acid, CH3COOH. This is the weak acid. Therefore, effect of added acid is nullified. Nullified means null means zero. So here we are adding H plus to this strong base. That strong base is converting into weak acid. Therefore, the added acid effect is negligible in this case. Therefore, pH is already, suppose this will have some amount of pH. CH3COOH plus CH3COONA is having some pH. That is the buffer pH. Suppose to this buffer solution we are adding what now? Strong acid. That strong acid is converted into weak acid. This is due to what now? It is due to reserve basicity which is present in the buffer solution. This is the reserve basicity. This reserve basicity is nullified the added strong acid into weak acid. Therefore, pH remains same. pH remains same in the reaction mixture. So this is what now? This is the first condition now. In the first case, if little amount of strong acid, that is HCl or H plus, is added to acidic buffer, that added strong acid, that is H plus, converts the CH3CO minus of acidic buffer into weak acid. Therefore, effect of added acid is nullified. Because it is due to what now? Reserve basicity. This is the reserve basicity. This is the reserve basicity is present in the buffer solution. Suppose if little amount of case 2, if little amount of strong base, that is OH minus is added to the buffer, solution, that added strong base That added strong base is converted into water. Is converted into water. Thus, effect of strong base is nullified. Effect of strong base is nullified. It is due to what now? It is due to already reserve SDT is present in the buffer. Reserve forces in the form of SDT is present in the buffer solution. This reserve SDT will nullify the effect of added base. So CH3COOH, this is the CH3COOH, it is present in the buffer solution. This is present in the buffer. This is present in the buffer solution. This buffer solution when reacts with the strong base, here we are, this is the added base. This added base converts this acetic acid into water. CH3COO minus plus water. So therefore this OH minus is converting into what now? Water. Therefore effect of strong base is nullified by converting into water. Therefore this is the what now mechanism involving in the action of acidic buffer solution. Suppose if you take the one buffer solution, it is CH3COOH, CH3COO Na. In this CH3COOH remains in unionized form because it is a weak electrolyte. But CH3COO Na being a strong electrolyte or strong base, that completely ionized in the mixture. Therefore composition of acidic buffer means CH3COOH is in unionized, whereas CH3COO Na is completely ionized. They will be separating into this CH3CO minus and Na plus. So in the case 1, suppose if we are adding what now? Strong acid to this buffer solution. Strong acid, the added acid is what now? Strong acid. That strong acid is adding to the what now? Buffer solution. The added strong acid is converting into what now? This is the weak acid. This is the strong acid. This strong acid is converting into weak acid. This is due to what now? Reserve basicity. This reserve basicity converts this H plus into weak acid. This reserve basicity converts this added strong acid into what now? Weak acid. This reserve basicity, this is present in the mixture. This is present in the buffer solution. This reserve basicity will convert what now? The added strong acid into what now? Weak acid. Therefore effect of added acid is nullified. In the same manner what now? This is here we are adding what now? One strong base. OH minus is a strong base, or NaOH added base. This is a strong base. This strong base, whenever you add it to this buffer solution, this added base is converting into what now? Weak. This is what now? Water. This added base is converting into water. Because this buffer solution is having what now? Acetic acid. This acetic acid converts this added strong base into water due to presence of this acetic acid. This is what now? This is a reserve acidity. This is present reservedly in the buffer solution. Reserve acidity. The reserve acidity is due to what now? Acetic acid. The reserve alkylity or reserve basicity is due to what now? Acetate anion. So this is the mechanism involving in the working action of acidic buffers. In the similar way, so working action of basic buffers. Working action of basic buffers. Basic buffer solutions. Basic buffers. So how basic buffers acting efficiently, and how this basic buffers will maintain the pH constant. For example, you take the basic buffer ammonium hydroxide and ammonium chloride. It is a weak base and it's salt of a strong acid, ammonium chloride. So this is a weak base and this is the salt of strong acid. So this is the weak, therefore it is weak electrolyte. This is strong, that's why this is the strong electrolyte. So this will be in unionized form in the mixture, unionized form in the reaction mixture. But this one is what? Now this is a strong electrolyte. This will be in completely in ionized form, completely ionized in the mixture. Therefore, composition of the buffer will be what now? Ammonium hydroxide plus ammonium plus Cl minus, ammonium hydroxide and ammonium plus ion and Cl minus. These are the components present in this basic buffer. So here, if little amount of strong acid, little of strong acid is added to basic buffer, what will happen? If little amount of strong acid is adding to basic buffer, what will happen? Suppose the strong acid means what now? H plus is the strong acid. This is the added strong acid. So this added strong acid is this is the acid. Therefore, in this what now? What will be the base now? Ammonium hydroxide is a base. So to react H plus, it needs what now? Base. So this is the acid. So what will be the base in the mixture now? This is acid. This is the base. So you take what now? Base. This NH4OH reacting with H plus to form what now? NH4 plus water. NH4 plus water. This H plus added strong acid is converting into what now? Water. This H plus is converting into what? Water. Thus the effect of added strong acid is nullified or not. So H plus is converting into water. Therefore, effect of strong acid added is nullified. So this is due to what now? This reserve force. What is the reserve force? So this is the base. So this is reserve. Here we are adding strong acid, but already in the buffer solution we have what now? Base, reserve basicity. So why effect of strong acid is nullified? Because of this reserve basicity which is present in the buffer solution. So the effect of strong acid added is nullified due to this reserve basicity. Suppose case 2. If little amount of strong base is added, if little amount of strong base is added to basic buffer, what will happen? Basic buffer, what will happen now? Suppose in the buffer solution we have already what now? NH4 plus. In the buffer solution we have already what now? NH4 plus. And this NH4 plus, now we are adding what now? Strong base. Strong base means OH minus. This is the strong base. This is the strong acid. Now reaction between them is what now? NH4OH. NH4OH is what now? This is the, again it is weak base. This is the strong base is converting into what now? Weak base. This is the strong base is converting into what now? Weak base. It is due to what now? Reserve alkylity, reserve acidity in the buffer solution. This is the reserve alkylity. This is the reserve acidity. Reserve acidity. Due to this reserve acidity in the buffer solution, that converts the added base into weak base. Therefore, the effect of added base is nullified. The effect of added base, this is the added base. The effect of added base is nullified into what now? Weak base. So strong is converting into weak. This is due to what now? Reserve acidity. This reserve acidity nullify the effect of added base. This reserve acidity, this is the reserve acidity. This will nullify the effect of strong base, which is added to buffer solution into what now? Weak base. Therefore, this ammonium hydroxide and ammonium chloride is acting as a basic buffer which maintains what now? Constant pH by adding what? Little amount of strong acid or little amount of strong base. So this is the working action of basic buffer solutions. So after this, we have the pH and pH and pOH of the acidic and basic buffers. pH and pOH of the acidic and basic buffers. So this is the pH and pOH of basic buffer solution. So before we going to discuss that one, we have one more point left, that is the addition of water. Addition of water to the acidic and basic buffers. Acidic or basic buffers. So what will happen now? Negligible change in the pH by adding water will happen now. Suppose you take what now? For example, this is the one container. So in this you take what now? That is the CH3COO. Actually for acidic buffer you take. For acidic buffer you take the acidic buffer. So what is acidic buffer now? Acidic buffer. Acidic buffer. Give one example to acidic buffer now, that is the CH3COOH and CH3COO-NA. Acidic buffer CH3COOH plus CH3COO-NA. CH3COOH plus CH3COO-NA. So this is the strong electrolyte or strong base, this is the weak acid. This is the weak acid and it is the salt of strong base salt. So what will happen in the reaction mixture? Suppose by adding water, what will happen? So CH3COOH, by adding water, it will becomes what now? CH3COO minus plus H plus. When acetic acid dissolve in water, what will happen now? It will undergo what now? Ionization, and in the ionization it will forming what now? CH3COO minus and H plus. Next CH3COO-NA. CH3COO-NA, by adding water it will forming what now? CH3COOH plus NaOH. And we have one more thing, that now what now? CH3COH is there, CH3COO minus. CH3COO minus. CH3COO minus. CH3COO minus plus water. What will happen? CH3COOH plus OH minus. So in the reaction mixture, we are getting what now? In the reaction mixture, in the first one what now? All these are present in the one container only. CH3COH when dissolved in water, here for all the components we are adding what now? Water. For all components we are adding what now? Water. This is the one component present in the acidic buffer. This is also one more component in the acidic buffer. This is also one more component in the acidic buffer. So this is the CH3COH. We are adding what now? Water. So when dissolved in water, it will dissociate into its corresponding ions. CH3CONA, and adding water, you will getting what now? CH3COH, and this is the base. This is what now? Base. This is the base. And but this is what now? H plus. This is the acid. This is the acid. Again it is what now? Base. This is also base. Okay. So Suppose you take one acidic buffer like CH3COH and CH3CONA. Now, upon adding water, what will happen? There is a negligible change. There is negligible pH change. There is negligible change in pH due to neutralization because this OH minus and this H plus, OH minus of this one, this also OH minus, this H plus forming the H plus formed in the reaction mixture. The H plus formed is neutralized the OH minus. That's why there is a negligible change in pH is happening by adding water to the acidic buffer solutions. Therefore, acidic buffers acting as this combination is acting as what na one buffer. That buffer which maintain what na constant pH, because in this particular container what na one is the H plus is forming. H plus is forming. The H plus formed in the reaction mixture neutralized the OH minus of this one, OH minus of this one, forming from CH3CO minus and forming from CH3CONA. That's why this buffer solution effectively maintains the constant pH on adding water. Therefore, on adding water, this solution will working as a buffer solution that maintains the constant pH. Therefore, this is the addition of water to the acidic buffer as well as basic buffer. So, same phenomenon will also with the basic buffers. This is with buffers with water, acidic buffer with water. In the similar manner, we have what na basic buffer with water will also there na. So now this is what na pH and pOH of the acidic buffer solutions. So for example, you take the CH3 COOH is the acidic buffer, CH3 COONA. This is the acidic buffer solution. So this is the acidic buffer solution now. So CH3 COOH is a weak acid ionized when dissolved in water to CH3COO minus and H plus, CH3CO minus and H plus, and CH3COONA also to CH3CO minus plus Na plus, CH3COONA CH3COOH when dissolved in water you will getting the CH3CO minus plus H plus. CH3COONA is a salt of strong base, also decomposed to CH3CO minus and Na plus. Suppose for this you write what na, this is the acid, therefore Ka is equal to what na CH3COO minus into H plus by CH3COOH. This is as per the, what is Ka na? Ka is the acid dissociation constant. Ka is the acid dissociation constant. Acid dissociation constant. So Ka is this one now. So from this you write for H plus. H plus is equal to Ka into CH3COOH, Ka into CH3COOH by CH3COO minus. CH3COO minus. Cross multiplication. So for H plus is equal to what na, one this Ka into this one by CH3COO minus. So now this CH3COO minus generally it comes from CH3COO minus of the acid plus it also comes from the salt, CH3COO minus from the salt. Generally you will getting the acetate anion from acid as well as salt, but CH3COO minus is a it is from what na acid. So acid is a weak acid, it never undergo complete ionization. Therefore its concentration is very, very less than the concentration of the CH3CO minus, which is from salt. Therefore, most of the salt is come from salt only. Most of the this CH3CO minus is coming from what na, salt only. Again, I will explain now. This is the one acidic buffer. This acidic buffer, when dissolved in water, it will be ionized to acetate anion and H plus. CH3CONA also ionized, but it is a strong electrolyte. That's why it is not the partial. This is the irreversible only. This is what now reversible. This is the irreversible. This is the strong electrolyte undergo complete ionization. That's why you're getting more number of acetate anions